My experiment 4 of lab 3, the ALU. So let me just explain my inputs and outputs and what I've assigned to which switches. So these 4 switches right here are my A input. This is 1 bit, it's 2 bit, it's 4 bit, and 8 bit. The 4 switches next to it, so these 4, is my B input. 1 bit, 2 bit, 3 bit, 4 bit. The 3 switches here all the way to the left are my control. 1 bit, 2 bit, and 4 bit. And this switch right here is my carry in. It's only going to matter in the add and subtract operators of this ALU, but this will be my carry in. And let me explain my outputs. I've assigned my outputs to these 4 LED switches. So this is my 1 bit, my 2 bit, my 3 bit, and my 4 bit. I mean, my 1 bit, my 2 bit, my 4 bit, and my 8 bit of my output. And then this green LED up here next to the 7 segment will be my carry out. So currently, I have my A input set to 0, and my operation is 0 as well. My control is set to 0, so that's automatically an increment. So that's why this LED 3 is on, because it's incrementing 0 by 1 and outputting 1. If I were to flip this switch right here, it would switch and power LED 2. Now this one power LED 1, and this one power LED 0. So currently we are at 7. So if I switch this operation to decrement, we should go to 6, and only these 2 LEDs should light up. So let's try that. And as you can see, only those 2 LEDs try up, and then only that LED tries up, because now we're at 3, so now we're at 2. Okay, so the next operation will be rotate. So let's try the number that I know. So let's try 7. So this is 7 right here. It should output 11. So let me just switch this to 2. And there you go. It is 11. So now for the shift. Let's just keep it at 7. And then once we turn the switch, it should output 3. So only these 2 LEDs should light up. So let's try that. And only those 2 LEDs light up, so it is working properly. Okay, for the next bit, let's do an AND operation. So now our B input actually matters. I've just left my B input at 0 because it hasn't mattered up until this point. So for AND, let's do 1, 0, 1, 1. And let's do 0, 1, 0, 0. So when we AND this, no LED should light up, because none of these LEDs corresponding at the same place. No one's corresponding at the same place, I mean. So let's do that real quick. So, and no LEDs light up. But however, if we push this switch and change it to an OR operation, all 4 LEDs shall light up, because they all have at least 1 1 in their corresponding placement. So let's try that. And all 4 LEDs do light up. Okay, so now let's add. So let me do an example from the carry, from the Ripper that we had. So let's do 11 plus 11. So this is 11, and this is 11. So what should happen is we should output a 6 with the carry out turned on. So LED 2 and LED 3 shall light on, and also our carry out shall light on. So let's try that. So our carry out is on, as you can see, that's the green LED, and we have 6 remaining. So our add is working correctly. So let's do subtract. So let's just flip the switch to perform the subtraction operation. And then since we're doing 11 minus 11, we should operate no LEDs. So no LEDs will operate. And then what if we wanted to do, let's say, 8 minus 11? So now we have 8 minus 11. And our borrow bit is on. And then, let me think real quick, 8 minus 11. So then 13 should output, and 8, 4, 13. So 13 is the remainder. our borrow bit is lighting up, also known as Cout. So our subtraction operation is also working correctly. And that is my ALU.